In this second lesson, we are going to study what independent and dependent events are, what conditional probability is, and how one thing is related to the other. Let's start with independent and dependent events. Like the name suggests, what is an independent event? Or what are two independent events, to be more precise? They are independent if the outcome of one is or doesn't affect the outcome of the other one. If you have two events A and B, whatever the outcome of A is not going to affect the outcome of the event B. However, if they are dependent, then the outcome of event A, the first one, is going to affect the outcome of the event B. As an example, I'm going to use a bag with 5 equal balls in it, but they are just numbered differently from 1 to 5. And you have two events. You take one ball first, and then you take a second ball. The events are independent if, after taking the first ball, you put it back in the bag. The outcome of the second event is not going to be altered by whatever happened in the beginning, right? But if you keep the ball out on the first event, then the outcome of the second is going to be dependent on what happened before. Particularly when it comes to probability. Originally, the probability is 1/5. You have 5 balls, so you have one event out of 5 happening for the probability of a certain number to show up, let's say. So that's 1/5. If you put the back in, the probability of the second event is also 1/5. All right. However, if after the first event you keep the ball out, the probability of getting whichever number that is left inside the bag is now 1/4. So event A altered the probability of event B. So we have here an example of a dependent event. Event B is dependent on what happened to event A. That's what I explained here. For whichever situation that regards more than one event, up until 3, more than that is actually a little bit complicated, but you won't have them. It's a good idea to build or to create a probability tree, such as this one. So if you want to determine the probability of combined events, you just have to follow paths using the probability tree. So let's say that you want to calculate the probability of event A1 and B2 happening. Okay. First of all, let's see at the structure of the probability tree. You have here on the first block event A happening. An example of that I gave before could be the probability of getting 5 or not. So in that case, outcome A1 could be getting a 5, the ball number 5, and outcome A2 could be getting any other ball. So this would be the probability would be 1/5 and 4/5. Okay. Then the event B would be the probability of getting any other number. All right. So if you get here 4, for example, it would be here 1/5, and here it would be anything that is not 4, 4/5. And the same thing over here. All right. That is for the case where you would put the ball back in. If you would keep the ball out, then the probability over here would be the same, but over here would be different because you would have only 4 balls left. So the probability of getting a 4 would be 1/4 and 3/4 for not getting it. Okay. Are you getting this? We are already going for conditional probability as I speak about this. The key idea for now is that you follow paths and you multiply the probabilities to get to calculate the probability of a combined event. All right, just follow paths and multiply whichever probabilities you have on top of these lines. That's how you do it using probability trees. Conditional probability relates to this. As you can see, the probability of getting the probability of the second event when you have a dependent event is going to be conditioned by whatever happened in the first event. All right. So generally speaking, how do you represent conditional probability? You represent it like this: P of B, and you have a vertical line. A means what? This means the probability of B knowing A, or given A. If you already know the probability of what happened in event A, what is going to be the probability of B? That's what this means. And this is always determined by calculating the probability of B and A combined. Okay, so if you have a Venn diagram, it will be this part over here. Or if you have access to the number of events, it will be the number of times B and A happen together, divided by the probability of A. Okay, it's always the probability of the thing that you have here to the right of the vertical line, or the number of events of the thing that you have, the event that you have to the right of the vertical line. Okay, just for you to know, the probability of B combined with A or intersection with A is the same as the probability of A intersection with B, obviously, as you can see here from the Venn diagram. Okay, knowing this, what's going to happen if you have either an independent event or a dependent event? If you have an independent event, this probability, again, the probability of B given A, is just going to be whatever the probability of B is. In the example before, it was 1/5. All right? It doesn't depend on what happened to A. The probability of getting the ball out of the bag, since you have 5, it's still 1/5. All right? So this means what? This means that the probability of the intersection of A with B, the probability of the combined event of A and B together, is just the outcome of the multiplication of the probability of A and the probability of B, whatever it is to begin with. If you have dependent events, now the probability of B is going to be slightly different, as we saw before. The probability of A is the same, but the probability of B is going to be slightly different. The probability of B knowing A is not going to be the probability of B only, as it was before, as you can see here. All right? Before, in independent events, the probability of B knowing A is the same as the probability of B knowing the complement of A. This doesn't happen when you have dependent events. So what does this mean? This means that the probability of combined events, A and B, is going to be the probability of A. That one doesn't change. But now it's going to be this multiplied by the probability of B knowing A. In the example before, this is no longer going to be the probability of B, which was 1/5. This is going to be 1/4, because now we know what happened in A, that is, one ball was kept out of the bag, so this probability changed. What I told you about probability trees is still valid over here, right? So once you know the probability of each one, regardless of being independent and dependent, and you construct your probability tree, to get the probability of a combined event, you just follow paths. And here you have all possible paths for this general probability tree. Okay? As a summary, I just added recently this table over here that summarizes everything that you need to know about independent and dependent events and conditional probability. What is the challenge regarding this? Is just interpreting what you have in a given question in English, so that you can create either a probability tree or a Venn diagram or whatever that allows you to determine the probabilities that you are being asked. Just one note: if you are asked to prove that an event is dependent or independent of some other event, you just have to follow this. If you calculate the probability of the two events separated, and this equals the probability of the combined events, so you prove that they are independent. If these two are different, then you have proven that they are dependent. Okay? So, again, calculate this probability, the probability of each one individually, multiply them. If they are the same, they are independent. If they are not the same, they are dependent.